Have you ever pondered the idea of infinity? I mean, truly considered the vast, unending expanse that the concept represents? It's not just a number or a theoretical idea, it's a profound challenge to our very understanding of reality. Let's dive into the mesmerizing world of the infinity paradox. Picture this, something that goes on forever. It's both fascinating and completely mind-boggling. Infinity isn't like the numbers we use in daily life. It's not quantifiable in the traditional sense, but is a concept that symbolizes boundlessness. In the realm of mathematics, infinity appears in various forms. There's countable infinity, like the set of all natural numbers, where you can pair each number with a natural number. And then there's uncountable infinity, like the points between 0 and 1, which, believe it or not, can't be paired off with natural numbers. This was a groundbreaking discovery by mathematician Georg Cantor. Now, let's talk paradoxes. Ever heard of Hilbert's Hotel? Imagine a hotel with an infinite number of rooms all occupied. Sounds full, right? But it isn't. If a new guest arrives, we can shift each guest to the next room, making room 1 available. This clever trick shows how infinity plays, by rules that are anything but intuitive. Then there's the Banach-Tarski paradox, a real brain twister from the world of geometry. It claims you can take a solid ball, split it into pieces, and, with the right movements, form 2 identical balls. It challenges everything we know about volume and mass, and relies on the axiom of choice, a controversial mathematical principle. And we can't forget Zeno's paradoxes from ancient Greece. Take the tale of Achilles and the tortoise, where Achilles can never seem to overtake the tortoise, no matter how fast he runs. It illustrates the baffling properties of infinite sequences. But what does all this mean beyond numbers and theoretical models? Infinity pushes us to question the very nature of reality, time and space. It opens debates among philosophers and scientists about whether infinity is an actual entity in the universe or just a concept to aid our understanding. Through developing tools like calculus and theories like transfinite numbers, mathematicians have found ways to grapple with these paradoxes. And in physics, infinity is everywhere, from the infinite density of black hole singularities to the endless expanse of the universe. So although these paradoxes might seem like mere intellectual games, they are fundamental to how we understand everything from the microcosm of quantum particles to the macrocosm of the cosmos. Infinity is more than just a concept, it's a journey at the edge of human understanding, a challenge to our finite minds and perhaps a gateway to the mysteries of the universe. The concept of infinity is a fundamental part of mathematics and philosophy, but whether it exists in a physical or empirical sense is a more complex question. Let's embark on a detailed exploration of the existence of infinity from mathematical, philosophical, and physical perspectives. In mathematics, infinity is a well-defined and rigorously treated concept. Georg Cantor, a 19th century mathematician, developed the theory of infinite sets, introducing the idea of different sizes of infinity, cardinalities. For example, the set of natural numbers is countably infinite, while the set of real numbers is uncountably infinite. Mathematicians use infinity in many areas. In these contexts, infinity is treated as a concept that allows mathematicians to reason about unbounded or limitless quantities. Philosophers have long debated the nature and existence of infinity, for instance, the set of all natural numbers as an actual infinite set. For example, the process of counting can continue indefinitely without ever reaching an end. Philosophical debates often revolve around whether actual infinity exists or whether what we encounter is merely potential infinity. Some argue that actual infinity cannot exist in reality, while others see it as a useful conceptual tool. In physics, infinity often appears in theoretical constructs, but is more contentious in terms of physical reality. However, this is still a topic of active research and debate. These infinities suggest the breakdown of current physical theories rather than the existence of actual infinities. In quantum mechanics, certain quantities can theoretically take infinite values, but in practice, these are often renormalized to finite values. Infinity in physics usually signals a limitation of the current theory rather than a true physical reality. Infinity, as encountered in mathematics and physics, serves as a powerful tool for understanding and describing unbounded processes and quantities, even if its actual existence is not empirically verified. Now that we've delved into the mesmerizing world of infinity and its paradoxes, let's explore another mind-bending concept, the infinity plus one paradox. This paradox challenges our understanding of infinity by illustrating how adding a finite number to an infinite set still results in an infinite set. To grasp this, we first need to understand the concept of cardinality in set theory. Cardinality measures the size or number of elements in a set. A set is countably infinite if its elements can be matched one-to-one with the natural numbers 1, 2, 3, and so on. For instance, the set of all natural numbers is countably infinite. Now, imagine you have the set of natural numbers 1, 2, 3. If we add one more element, say 0 to this set, we get a new set 0, 1, 2, 3. Intuitively, you might think this new set is larger than the original set, but here's where infinity plays its trick. Despite our intuition, the new set is still countably infinite and has the same cardinality as the original set. How is this possible? Well, we can establish a one-to-one correspondence between the elements of the two sets. We can map 0 to 1, 1 to 2, 2 to 3, and so on. This mapping shows that the two sets have the same cardinality, both being countably infinite, so adding a finite element like 0 to an infinite set doesn't change its size. The infinity plus 1 paradox illustrates several important insights about infinity. First, adding or removing a finite number of elements from an infinite set does not change its cardinality. This property is unique to infinite sets and contrasts sharply with finite sets. Second, our intuition, which is shaped by finite experiences, often fails to grasp the properties of infinite sets. Concepts like larger and smaller lose their conventional meanings in the realm of infinity. Understanding these properties is crucial in fields like set theory, calculus, and number theory, where infinite sets frequently appear. So, while the infinity plus 1 paradox might seem counterintuitive, it reveals the fascinating and often perplexing nature of infinity. Infinity, in all its forms, continues to challenge our finite minds, pushing the boundaries of what we think we know about the universe. And as we peel back the layers of these paradoxes, we find ourselves ever closer to the profound mysteries that infinity holds.